even on WhatsApp. That's my phone number on the screen. They also provided this is made available to you on the LMS because I've uploaded the course outline, and it has the same thing you are seeing right there. And then if you also want to send me an email, that's my email, isenche@gctu.edu.th. For those of you who are around and may want to come and see me, I would rather ask that it should be per appointment. And then I'm available on Wednesdays, 8 to 10, and then 1 to 2, Fridays, 8 to 11, then 1 to 2. Because of you, Saturdays, yes, I'm available. In case after the class I'm available, we can talk. In case you want us to. Aside from these periods, in case you also want to call me, I want to encourage that you probably may want to send me a text, a WhatsApp to find out if I'm available for the call or something. I believe that would be good, and we can take it on from there. So with this, this one entails the course description. We'll look at also the objectives and some of the things that you will be equipped with would be to understand why databases are essential in modern information systems, running through to even understand how databases are designed, structured, and then accessed. There are a couple of them all through to even appreciating the future trends shaping the field. And for the requirements, I want to encourage, your participation and engagement. And then also let's be actively involved in what we do here. One of the things that I always will say for me, my class, is that please, we do not have right or wrong answers. And the reason I adapt to that strategy is that I want to encourage everybody to share their bit, their thought, what you may assume be wrong or right. You go ahead and share it. And then I have the right to polish it up, work on it. So we don't intimidate others. We don't push them down. We don't make them feel, in quotes, like they do not belong here. We offer them the opportunity so they can also ask their questions, share their thoughts on certain things that I asked right in here. And again, we are not here to mark grammar. So allow people to express themselves and don't tease them and make them feel terrible, please. Allow them, right? Okay. And I want to encourage that you read on the subject and topics that we will be treating in the next units. Already I've uploaded Unit 1 together with their sections 5 in there on the LMS. Also, when I give an assignment, please, I want to encourage that you stick to the deadline, and I am very firm on that. Please, let's keep to that, and I think it would help every one of us. When I give an assignment, you have to type and maybe present it, because we are a university, and just so we don't plagiarize, I want to encourage that you do proper intercitation, and then also you reference your. Is there anybody asking a question?
Hello, sir.
Yes.
Sir, please, your voice is down.
My voice is down?
Yeah.
Hold on. Oh, I get it. Is it okay now? Can you hear me? Is it
Yes,
better?
please.
Yeah, it's
loud
okay
and
now.
clear.
It's okay now.
Oh, fantastic. I'm sorry. So I'm using a headset, not knowing I was rather speaking through the one on my laptop. So what didn't you hear? So I go back to pick them up again. Should I start the whole thing? Is there anything you missed?
So you can start from the assignment side.
Okay, so all right, thank you very much. And then also thank you for prompting me on that. So with the assignment, when I give you an assignment, please let's stick to the deadlines that will be given. Also, if it has to be typed and all that. It has to be properly done. And then also do your correct referencing. This university agrees with the Harvard style. And then also you do proper justification of your document. And then you check the spelling and the grammar as well. Again, I want to encourage regular attendance and then promptness. And then in case you want to absent yourself, you can keep me posted. You can also inform your course reps, and then they would also communicate that to me. For the lecture slides and all that, please, I upload them as and when they are ready. And this is already ready and uploaded on the LMS, so you can access it now. Maybe somebody can check it now and give me a feedback whether you can access it. Kindly check it and give me a feedback on that. Also, I want to encourage you, you can read some of the textbooks that are listed right in here. Of course, these may not be the newer versions. There are newer versions out there you can go for, but the ones I have listed here are free. You can access them online. And then also you can read some other materials on the World Wide Web. Most importantly, I want to encourage that you read peer-reviewed publications, journal publications and conference publications. The university, through the library, have access to IEEE, journal and conference publications. Also, now we are doing a test run of our access to the Web of Science. And so when that also becomes available, you have, a wide access to a plethora of, publications from Web of Science, which will be great, okay? And then also you can do your private studies and all that, which would help. Now we are going to be having online, face-to-face will be here 2 times in the semester. There will be some presentations that would be done. So you'll be in group. Yes.
Point of correction, only one face-to-face.
Only one face-to-face. Thank you for letting me know that. I'm excited about that. That's good. Thank you. I was informed it was going to be 2 times, but if it's once, then I'm already excited. Thank you. Okay, so then of course our mid-semester exams will carry 25%. Your group presentation, which will be a project assigned to you, would be 10%. Attendance will carry 5%. Then the end of semester exams will carry 60%, which makes the 100%. Now, throughout the week, the weeks we are doing, technically we are doing 10 weeks. The 11th week is supposed to be our revision week. Then the 12th and the 13th weeks are supposed to be for our exams. However, because of how the course is structured, hopefully the 11th week, which is supposed to be our revision week, we are likely to treat the unit 10. But if it so happens that we are able to move very fast, then we can have it under the other weeks and then have our 11th week as our revision week. Now, I've also indicated for those of you that wants to know, I know most of you are working, but for some of you that may want to now switch careers, advance, to other areas and all that, I have listed a couple of some of the things, prospects and opportunities for you in terms of career, the path, data administrator, database administrator, data analyst, backend developer or software developer, system analyst, business intelligence specialist. And then also there are certain emerging and high demand fields, which will be the data science. Those of you that want also go into that area, data engineer, cloud computing, cybersecurity. These are also emerging high demand fields that pays very well around the world. And of course, for what you are studying, it's needed and applied within the banking and finance area, telecommunications, all through to e-commerce and tech companies. And if you also want to look at freelancing and then also entrepreneurship opportunities, they are there. If you want to grow through from entry level all the way to senior level, also these are the opportunities and things listed to guide you. I want to encourage, I always will say that don't limit yourself to just what we teach. and get the certificate, and that ends it. No. Roxanne is asking whether he's the only one who cannot see the screen. The others can see, or can you all see my screen anyway? Or is it just Roxanne?
Yes, please. Yes, please. You can
Yes,
see.
Thank you. Then Roxanne, I want to encourage that you go out and come back in, okay? Or you can restart your machine. All right. Thank you. Right. So I want to encourage that you take some certificates, some certification courses. This adds certain value to what you are doing so far, and then it separates you from the rest. It's like having, I normally want to use David Beckham. And Beckham, we all know how he improved with his free kicks. And we got to hear that when they are done, the corporate training, he will go the extra mile, spend some more time taking free kicks until he feels certain pain at his hip joint. And on the D-Day, we all see how he dazzles. All right. So what can separate you from the others will be the extra work that you put in. And so if you want to take some certification courses, it would help you. It will put you a notch higher and make you competitive. So yes, we have for beginner level certifications, Microsoft Certified Azure Data Fundamentals, Oracle Database Fundamentals, Foundation, sorry. Google Data Analytics is also right there. Intermediate certification, you can also look at Microsoft Data Analyst Associate, Oracle Certified Associate, IBM Data Analyst Professional Certificate. Then if you want to traverse the path of advanced certification, you can look at AWS Certified Database Specialty, Microsoft Azure Database Administrator Associate, and then Certified Data Professional. These are some of the things that you can explore, which I believe can be of help. I want to allow opportunities for you to ask questions. If you have any question to ask me, you can go ahead before we now even zoom into looking at what we have to treat today. Do we have any question so far?
So, this is David.
Yeah.
Please, I want to ask, so with the midterm, are you going to host it online or during face-to-face?
No, I'll do online. I'll do online.
Okay.
Yeah.
Thank you.
I want to be as flexible as I can to help.
All right, thank you.
Yeah. Any more questions, guys? I know you guys are working. Yes, sorry. Go ahead.
Hello, sir.
Yes.
Good afternoon.
Good afternoon, sir.
Please, I want to ask, are we going to use any, let's say, softwares for the modulo? Maybe there are specific softwares or applications we are supposed to get to aid learning and teaching.
We are basically going to be using SQL. So MySQL is what we are going to be using so far when we get to that level.
Okay, sure.
Yeah.
Thank you very much.
You're welcome. Do we have any more? Any more questions? Okay, if there are no more questions, I want to try and then finish it off within this period because we have got 6 sessions to go. And then, yeah. All right, so if there are no further questions, I believe we can start. All right, please, if you want to ask a question, I'm not sure I'm looking at the participants, so I don't get to see your name and all that, but you can mention your name. So I want to familiarize myself with your names. I want to familiarize myself with your names. I want to know your names, okay? Because we only get the opportunity to meet once, basically. So at least help me to know you by name, right? Okay, all right. And then also I'll try as much as possible to upload writing one of the books which will be Database Systems Design, Implementation, and Management, 13th edition. All right, I'll also put it on the LMS to help. Is that okay? All right.
That's fine.
Okay.
That's fine.
Thank you. Thank you. So for this particular unit, this is basically going to provide us, foundational understanding of database systems. And running through, we'll be exploring the basic concepts of, data, information, and then also database, running through to even looking at the various types of databases that we have. Then we'll go through the processes that we have gone through until now to have our database. But of course, it started with the manual file system running through to the computer file system. And then we ended up coming into embrace databases. So we'll go through these ones. All right. And then, so obviously some of the topics we are going to be looking at for this particular unit will be these. But for this section, we are going to be looking at data. And at the end of the day, you should be able to define data and information, and then be able to differentiate the two, and then explain what a database is, and then even identify some examples of databases in real world. Now, a quick question here before I even jump off into looking at the issues right in there. When we say data, what comes into your mind when we say data? When we say data, please, if I'm moving fast, draw my attention to it. Okay. Yeah. When we say data, what comes into your mind? Data. I'm sure by now we have heard a lot. Oh, data here, data there. And one of the things that we are so used to would be my data is finished or my data is running out. And when we say our data, oftentimes we are referring to the data on our phone that allows us to get internet, right? And so people have been making, basically expressing themselves with that or saying such. My data is almost finished. This file is too much. It will deplete my data. It will do this. It will do that. But in the context of what we are looking at, database concepts, when we say data, what comes into your mind? Any idea?
Okay.
Yep.
All right, sir.
Yes. May I know who is speaking?
Okay. So this is Edward Bedo.
Fantastic. Go ahead, Edward.
Okay. Data is a raw facts or values.
Okay. So when you say raw facts or values, how do you mean?
That is like dates and numbers and names and values.
Okay, great. Thank you so much. Really appreciate it. Is there any other person that also want to share something else? Thank you, Edward. I appreciate it, sir. Okay, so what Edward said is, yes, go ahead.
This is your plus. So
Go
I
ahead,
would say
Theo.
that data is unprocessed, raw unprocessed data. Let me put that way. That is
All right.
yet to be processed to information.
Thank you. Thank you very much, Theo. I appreciate it. Has it crossed your mind? We say database, all right? Database. But when you separate or when you look at the word, it's actually two words that have come together. Data and then base, meaning the base of whatever the system we are looking at is what? Data. The foundation, the core component of that system is what? Data. Database. So it will be ideal then for us to find out what that particular data is. And as Edward and Theo have already said, data are actually what? Raw facts, figures or symbols that have no meaning on their own. You see, it is raw. It doesn't make sense. It doesn't have any meaning. It doesn't really have any expression behind as it is represented. An example of such would be, as they have already said, you pick numbers. I mean, if you see 25, 89, 190, what is it? It doesn't really make sense. And whilst one person would say that it probably looks like maybe results. Okay, somebody will say this one looks like results, exam results or marks. Another person may say maybe it looks like population of people, number of people. You understand? Another person may also give it another thing, because as it stands or as it is, it doesn't communicate anything. It is raw. It is ordinary. There is no meaning to it. Much the same way, when we see John, Adam, Abbas, and even when we see Boli, maybe Boli because of the happenings, the recent happening. But to be honest with you, it doesn't really make sense. If I present this to another person, so what is John? What is Adam? What is Abbas? What is Boli? Or maybe another person, depending on where they are coming from, will say, what is Bol? What is it? It doesn't make sense, right? Again, scores. Even if we target by numbers, by names, by scores, yes. So if you tell me the scores are 45, 78, 90, and so what? Letters, DYBO, and so what? Okay, even when you give me images, and so what's so special about those images and the symbols that you are showing me? All right, it doesn't really communicate anything. Hence, it is really raw. It is really raw. Now, data are likely to be managed most efficiently when they are stored in a database. This is where it brings us to the level where we can now come to terms with what we are doing so far. How we store matters. And at the end of the day, one of the key things that we need to understand, the one that controls the world is the one that controls data. It's not the one with ammunitions. People may have ammunitions, but when they don't have the right data, they will not even be able to put it to use. I don't know whether you have noticed. The reason there's so much tension between certain countries would be who is now leading, the data ownership or data possession. As it stands now, China appears to be ahead of most of the countries, including the United States of America. And so they will not have it lightly, but they are the ones who are also producing most of the systems that we are using, that are also harvesting, processing, using data. Huawei products are there. Most of the cameras we see around mounted on our streets all over. One thing that I heard in the UK, specifically in London, was where they raised a concern about the cameras around, and they wanted to even cancel a contract they had with Huawei. Why? Because they said that they were encrypting the feed of these cameras and were sending them to what? To China. So in other words, they were just taking packets of these data that were coming through the feed that they have in their streets. Okay, and then their buses and all that, and sending them to China. And they were alarmed. Why? Because they know what they can do with that, though it may appear to be raw data. But again, now when it switches from the raw and it becomes the information, in other words, when it has been processed, then it will begin to reveal certain meanings. So what we are saying by the information here would be the result of processing raw data to reveal its meaning. As raw as it is, it doesn't make sense. But the moment we start processing it, now we can make some inferences. We can now deduce some patterns out of that. We can forecast. All right. It helps us to make such things. Right. And to reveal the meaning, information requires context. So for example, an average temperature reading of, let's say, 102 degrees does not mean much unless you also know its context. So what is the context? Is this in degree Fahrenheit or even Celsius? And also, what is the context again, being it, is this machine temperature, a body temperature, or outside what temperature? And then we will begin to appreciate, what you are dealing with. So information can then be used of course, as the foundation for decision making. Let me cite one clear example that will help us. For example, we all know that we do population census every decade, right? I hope we know that. So the last one that was done was it 2020? Ghana population census. 2020, right? I'm not really sure about that, but I want to be sure if any of you remember. The last population census that was done in Ghana was in 2020. Now, when you go back and check, when they deploy these officers to the field to go and gather the numbers, okay, or to record of the population of household, communities, municipalities, and the likes. Yes? Is that correct?
2021. 2021.
2021. Oh, is
Yes,
it because of the COVID? Because I thought we do it 10 years interval.
Yeah, so it was supposed to be held 2020, but COVID disrupted.
Yeah. Thank you. Meaning that the next one is most likely to be done in 2030. If by then there is no other COVID kind of happening or situation, then yes, hopefully we are likely to do it around that period. Okay, so now, you see, when they deployed those officers out there, one of the things you realize would be they go to the houses with forms in hand, they start asking questions. Okay, so how many rooms do you have in this house? Then they will say it. Okay, so how many people live in here? How many are maybe babies? They'll give an age bracket. How many are maybe youth? How many are adults? How many are aged? They collected all these things. Now, when you look at what has been collected so far, you realize that they are just, because when you now put them on an Excel sheet, they are just numbers that are sitting there. Okay, different numbers and names and all that. They will not actually make sense. But now, when we put them together, process them to now identify how many people live in a municipality. Okay. From then, we can then take a decision in maybe creating another constituency or maybe leaving it as it is. I hope it is making sense right now. Why? Because, you see, now the information we have gathered, in other words, what we have processed, the data we have gathered and we have processed to now get information out of that, we can make a decision as a country to create more constituencies or maybe to collapse the constituencies we have. It's the same thing when you go also into the industries. For example, when you go into, let me even use the ShopRite, any of these grocery shops or institutions. You also see that one of the things I noticed in one of the places is that, or one of the things you see would be when you are about paying, making your payment to exit, you also will come to see that they have positioned or maybe displayed certain products at those places, at the tills, at the cashier's end. Now, one of the things you come to also understand would be the fact that it was not just put there, in most cases, for decoration's sake. I read from one of the places, and in fact, one of the places I worked in London, which is Sports Direct, we decided on displaying certain items at certain vantage positions and places because of what we studied over the period, data we collected over the period, and based on that data we collected, we made some information out of that. What is that information? A typical example. They realized in one of these grocery shops out there that it is the men, all right, the men love to buy beer, especially when it is soccer period. So this World Cup period, you see most of the men will go to the grocery shops and go and buy alcohol, just so boys can sit down and break some bottles. Now, so when they are going to some of these places, okay, these places, being it Walmart, being it Kohl's, being it Morrison's, being it whatever shop that you know of, all right, when they are going to grab the the beers and those things, it will be ideal for them to position diapers or sometimes even condoms around such places. Why? Because it will be easy. Their eye will catch that. They remember, oh, my baby needs a diaper. Oh, I need to get a condom. At least when I am hot, I can clear off with that. So they just don't move items for just moving them around. They would have taken a decision based on the information, which of course would have been fed in through the data they would have collected over a period of time. I hope that makes sense. Right. Now, to make a very good decision, right? One thing that needs to be highlighted will be the accuracy of the data. Okay, or even the information, how relevant it is and how timely. These are good things that are actually going to help you, make a decision. It is going to help to make a decision. A clear example again will be the fact that one of the students I handled some years back, I think 8 or 9 years back in this school, he shared this story with me in class. And this guy was a mature student. Wait, somebody's annotating the screen, and so mistaking it, but I want to see if I have the admin right to take off that. Disable annotations. Okay. I've disabled that. All right. Sorry about that, guys. Somebody was just by mistake, I want to believe. So this guy shared this thing with me. He was part of the officers that did the population census some years back. And then he told me this story. I'm sure some of you may corroborate what I'm saying right now. If you can share, if you are a witness to this one, you probably can share your experience with us. This guy said that anytime they went out there to the field, in some of the places or areas they went to, especially the villages, and when they came back with the report, whoever would be supervising them will go through and go like, no, this one does not reflect of what we are looking out for. Why? Because they would have done a projection that says that maybe in a village, the number should have doubled over the period of 10 years. But these guys have been to the field. And when they went to the field, this is what they are reporting. Their report says that, no, this is the exact reflection on the ground. But these guys are also saying that, no, we project that we should have about twice what we recorded the year before. Well, I don't know what is informing that decision, but sometimes we also forget that people migrate. Certain other things may happen and people may want to move from places, especially when there are no jobs there. Why would the youth want to settle in there? They would move. Okay, go back and correct what you have reported because it doesn't reflect what we are looking out for. They are also saying that, no, this is what we saw. This is what we are reporting. This is the exact thing on the ground, just so they avoid the banter or maybe the back and forth. And they are also paid. Then they go and sit somewhere, pull up forms, and then fill with ghost or maybe dummy data. I hope you are paying attention to what I'm saying. Now, if they fill with data that is not the true reflection on the ground and they present it, then it also comes in to say that indeed, all right, now we are going to make a decision. The decision to maybe increase some more constituencies would have been fed in or would have come through from what have already been told or been presented, which may not be maybe the exact or true reflection on the ground. So now we are creating more constituencies, meaning we are going to have more people in parliament, meaning we are going to now pull more on the national cake or resources. About 270 something people are going to sit in parliament. They are going to be paid. They are going to be given certain resources. You can just imagine the decision we are taking as a country when indeed it is not maybe the true reflection on the ground. So it is always good. There should be accurate information, relevant, and then it should also come in timely to feed our decision. All right. And remember, when the decision is good, it's going to help with the survival of that business, that institution, that community, and all that. So in fact, data are the foundation of information, and information is the bedrock of knowledge. Out of that information, now we can decide. Knowledge is the body of information and facts about a specific subject. So yes, we are saying that it should be timely and useful information, and that requires accurate data. All right. And how we generate the data also matters. So we are basically walking a path to bring us to the place where we come to understand why we need to now even create database. Okay. And this is because if we don't generate data properly, if we don't store it in the right format, and it's also not accessed in the right way, it's not processed in the right kind of a way, it is going to affect the outcome or what we intend to use it for. So it will be ideal for us to manage data and even the environment from which we generate it from. So how then do we, or what is data management? Data management then is a discipline that focuses on the proper generation. So of course, how we produce the data matters. All right. Then also storage, how we store it and the format, and then how we even retrieve it. So the discipline that focuses on the proper generation, storage, and retrieval of the data. And for us to have, to efficiently manage our data, you and I would agree on this one. Much as it will be okay to be having, the manual way, have a pen, a book, maybe a pencil and a book, record your stuff. Sometimes others may also want to keep it in their head and all that. It is not too efficient. If you are dealing with a few data, yes, but when it grows, when it extends into their thousands, into their millions, how do you handle that? So the right way would be where you use, a computer database. So then database becomes an important item to consider, and that is a shared integrated computer structure that stores a collection of end user data, the one that is going to be used in it. We will get to know the different types of users and all that, right? All right. Their data, and then also the metadata. Metadata is basically talking about data about data. So for example, the metadata, when you pick something like name, that is data, name. Okay, first name is data, first name. Now, the metadata about the first name will be the data type. The data type will be the type or the right format for it to be stored, which in this case, we are saying it should maybe be character char or maybe var char. Others, depending on what you're using, will be string. Okay, when you are dealing with age, which is data, age, one of the data, metadata about that will be the data type of that age, which will be integer. Okay, if you are dealing with the name, another metadata of that will be the data size. So if it is first name, while some people have short first names, others would have a very long one. Some people may have two names to be their first name. So that metadata about the first name would be the data type, will also be the data size. Is that okay, guys?
So
Are we
please,
clear on that? Sorry?
please come again on the metadata.
Okay. All right. Let me use another example. Have you all worked with Word document before?
Yes, please.
Okay. When you pick the Word document have got other things about it apart from what you put in there and all of that. Okay. The metadata about that Word document will be the file size. The file size. Then the format. So the file size, is it 15 KB? Is it the EXT, or is it TXT? You understand? Depending on the version that you're using. Okay. Then the date that the document was maybe created. Then the author, or the one that owns it. So this is also the data about that data, that Word data. The other data about that Word data are the things I have mentioned: the author, the date, and maybe the time that that Word document was generated or produced. Then the size of it. Okay, the extension, the file extension. So this is also another data about that data. And I said a similar example would be when you pick, for example, let me just pick a highlighter or maybe a pen. When you pick name, I'm trying to write well. Okay. We may pick name as maybe Kofi, all right? Forgive me if it's not writing well. This is data. That data is Kofi, okay? But, so this is data. Then the metadata about Kofi, all right? The data about this data, called Kofi. Meta would be, for example, the data type. Okay. Again, we may have the data size. So what is that data type? The data type will be, maybe you may declare car or character. Okay. Or another may say varchar or varchar, depending on where you schooled. Okay. Then the data size would be, so we say the size should be dependent. This is supposed to be bracket. So if it's not coming out right, forgive me. It's supposed to be bracket. Then somebody may say, okay, for me, I want the size to be 20 because maybe in the future, we may have somebody who has a very long first name. Somebody may be called Melchizedek or Zerubbabel. Very long names like that. And some of them may even have hyphen. So you see, the data is what, Kofi? But the meta data, which is the extra data about that data, Kofi, would be what? The data type, the data size. And that would be these ones. So is that okay now? So the database stores the data from the end user. Then it stores the metadata also. Is that okay, guys?
Okay, sir.
Yes.
If I understand, that means the data Kofi, there's a sub-data too as well, which is the metadata.
Mm-hmm.
Is that
Every
it?
data has, yes, every data has another data about the data.
Okay, I get it.
Mm-hmm. Mm-hmm. Another example, the data called age. Age. Now, who can share with us? Maybe what is the metadata for age? Age. Apart from, let's say your age is about 45. Okay, what is that metadata about that? Pardon me, about that age? Is there anybody that want to share thoughts on that? Or may want to contribute?
What is it?
Yes, go ahead.
Maybe an integer.
Okay, so you can say
Integer.
Yeah.
Good.
you can
Go
say the
ahead.
metadata can be probably the year in which you were born.
If you pick the year and that the year is also a data, then you are rather looking at date of birth. Okay, even if date of birth and we pick even year is data on its own. Remember, what is data? Data is raw facts and figures. Okay, data, that is the data. So year is also data. But the data about that year, which is maybe 1980, the data is 1980. But the metadata about 1980 would be maybe the data type. Somebody said integer.
Yeah, that's me, sir.
Yeah, you
Hello.
said integer. Yes.
So like in layman's terms, can we say like the metadata is sort of like the attributes of the main data in a sense?
Yes.
Okay.
It is okay. It is okay to say that. All right. The attributes of that data itself can also be, you know, as a metadata. All right, if we understand that, then I guess we can move on.
Yes.
We can move on.
Yes,
Fantastic. Now, let me clean the screen. So now the data in a database is typically organized into records. We will see what a record is. But just so we know, you see, a database would be the container itself, all right? Then in that container, we would have records. So for that database, we can have employee record. We can have medical record. We can have department record. We can have student records, lecturers records. And these are in a database. So when you pick a database like GCTU database, okay, you can have employee records. You can have maybe access in terms of, no, asset records, the things we have around. Okay, you can have student records. Okay, now let's look at any of these grocery shops. Let's pick ShopRite. What are some of the records that comes into your mind? ShopRite.
Inventory records.
Inventory records, yes. So again, somebody will also pick it in another way. Instead of saying maybe inventory, somebody may want to break it down. Okay. Yes, another person may want to go further to say, yes, inventory records is indeed true. It is correct. I don't even need to break it down. It's correct.
Stock.
Any other person? Inventory stock, yes, same. Any other person? Any other person? You can picture Malcolm. You can picture Orca Deco. You can picture ShopRite, Game.
Like products records.
Products. Fantastic. Any more?
Sales records.
Sales. Great. Great. So you see, the database that
Expiring
belongs to
date
that is
record.
expiring date. That will go an extra mile. That is if it comes out to be, I don't want to use a term that will confuse you right now. If it becomes necessary, else that expiring date becomes a part of the product records. Because when you pick any product, part of the data on that product would be the product name, the product ID, okay, the expiration date, all right, and maybe a few other things, the origin, the manufacturer, and a few other details that comes with that. So yes, the expiry date can also be under the product record. But if we get the concept of what record is, I believe that this would help. If we understand that, can I move on, guys?
Yes, sir.
Fantastic. Okay. So having known this, we will need to now manage our data. Okay. And we have looked at it. We said that it's a discipline that focuses on the proper, generation, storage, and retrieval of data. This is looking at the data management itself, but we would have to manage the database. And if we are managing the database, then remember the database contains records. Okay. Then what comes in there? This is supposed to be corrected. I'll correct it and upload it again. It's supposed to be database management system, not data management system. I'll correct it. Okay. Database management system. Now, so this would be the system management system for the database, which contains the records. And I've told you, when you break it further down, the lowest component, the core, the cell, is like the body, human body. The human body, the smallest, minutest item in the human body is the cell. Okay. And then the cell comes together to form the tissue. The tissue comes together to form organs. The organs put together will form the full body system. Right? So the cell of the database is the data. Okay. Then the rest of the things we will get there in future. But for us to manage the database, or what it is a collection of programs that manages the database structure and controls access to the data stored in the database. So it's doing a lot of work right in there. You may want to go with this definition, or you may even want to look at the role it plays, and then you will let that help you in your definition of what a database management system is. All right. It helps you to manage what your database structure, the structure of the database itself. It's like having somebody managing a building. The building would be the database. Okay. And then how people now access that building. Okay. All right. Assess the things that are in the building. So in this case, assessing the content of the database. So the database management system comes in to help us to manage the database structure, and then even accessing the content of the database. And the DBMS serves as the intermediary. It sits in between the user and the database. I'm going to show you a picture in the next slide. So what now sits in between me and then the database I use, you and the database you use, and every one of us use a database. We use database almost every now and then. We are using database. You are using databases of Facebook. You are using databases of Google. You are using databases of certain other big institutions around the world. Okay. Now, what's sitting between us and those ones would be what we call the DBMS. All right. Now, the database structure itself is stored as a collection of files. Again, a new thing has been introduced. The database structure itself is stored as a collection of files. We will get to appreciate what the files are. And the only way to access the data in those files is through what? The DBMS. All right. Okay. Again, I would also chip in by saying that picture your database, okay, to be like what? An electronic filing, cabinet, a file cabinet. How many of you have seen a cabinet before? If you are in most of these government agencies, even some of these private institutions still have got cabinets where you pull the drawers, okay, and they have got folders sitting in them. Sometimes they have named the folders, they have given them letters or coded them, as it were. So the database acts like an electronic filing cabinet, okay? But for this one, the software that helps you to manage the content of that cabinet will be what we call the DBMS. Is that okay, guys?
Yes, sir.
And
Yes,
fantastic,
sir.
thank you. So what is the role of the DBMS? It presents the end user with a single integrated view of the data in the database. It also receives all application requests and translates them into complex operations required to fulfill those requests. So for example, you want to maybe check your bank balance, okay? You want to check your bank balance. It is the DBMS that receives that request of what? Balance. Checking balance. You see, when you go to the ATM, after entering your PIN, by entering your PIN, it gives you access to now see the content. It's also a request because your PIN gives you access. It sends a request that, hey, I want to be able to check on this particular account using your ATM card and your PIN. All right. Now, that is a request is sent in. The DBMS allows for you now, it changes whatever you have entered, and then it sends the request into the system. So it grants you access or not. It also hides much of the database's internal complexity from the application programs and then also users. So you don't get to see, you're not meant to see. In fact, yours is just to go deposit, withdraw, and all that. What business have you got to do with knowing how the system works behind the scenes? It is not your job. Your job is dump your money, get your money as and when you need it, and that's it. Why do you want to know the details? So the DBMS hides some of these things from us. Right. Now, having mentioned database also comes in different types. I think I need to move a little fast, right? Because we have done like 1 hour, 3 minutes already, and I'm still on section 1. Should I speed up a little bit?
Yes, sir.
All right, thank you. Right. The DBMS as it is, we have seen it, it hosts the database in it, right? So much as it is now managing the database, right? Remember, it's managing the database, it also managing the access to the things that are stored in the database. So obviously it supports, it will have database in it. And there are different types of databases that can be a component of your DBMS, all right? But one of the things that will help us to now identify one database from the other will be when we are using, for example, the number of users. Okay, people that can use the database. Now, where the database is also located, the data that it stores, then also what it is even going to be used for or what it is used for, then as to whether what it is captured in there is structured or even unstructured. So, for example, based on the number of users, all right, it will tell us whether it is indeed a single user kind of a database or it is a multi-user kind of a database. And for one to qualify to be a single user database, of course, remember the name is what? Single user. You are the only one that use it. So if let's say you are using it, the rest of us cannot have access to it until you are done. Then another person can use it. It's one person at a time. It doesn't take two. And one example of such will be your desktop database. Now, beyond that also, we have got multi-user, meaning that if it goes beyond, or if let's say more than one persons or people can use a database, then it tells us that this is no more a single user database, but it is a multi-user database. But under that, we also have got two different types under that. We have work group database, which supports usually fewer than 50 number of people, or the enterprise one that goes from more than 50 and usually in the hundreds. All right. Then we can also classify database based on that location where it is. It can be centralized, meaning it is positioned at one particular place, a single site, or it can be a distributed version where we have them at different, sites, different locations, which are independent of each other. Okay, they are distributed across different sites. We can also have a situation where we have it now based on what data it is storing. Okay. Now, when you look at contexts such as the research environment, it can even be a guide for us. And for some of these ones under this, so what is the purpose of that particular data that is storing? Is it a general purpose? Or maybe it is discipline specific. It is meant for a certain area. It is meant for, so we can have those that are, for example, census database, all right? And that is a general one. That can be a general one, all right? Of course, why? Because it contains the information, the demographic data of people and all that, right? So yes, it contains almost everything. But when you come under specific ones like discipline based ones, you go to a place like, I don't know whether I can get the name correct. Is it the Seismic Agency of Ghana? Those that monitor the earth tremor and then the earthquake and those things in Ghana. So they also have got a specific database that collects data on some of these things that are happening, natural happenings in Ghana. For example, when, I don't know whether any of you have experienced an earth tremor before. The earth shook a little bit one time. If you live at Gbawe in Accra, if you live even the university campus at Tesano in the police school, we are sitting on, I hear, is it an earthquake path in Ghana? So sometimes, and I've experienced it here in this school like 2 times, sometimes you feel like the earth is moving a little bit, like it shakes. When these
Yeah.
experiences occur, sorry,
I was saying that's true.
fantastic. Also, that means you have experienced it before.
Yes, that's
Great, great. I used to live at Gbawe. I have experienced another time where it shook. That one I experienced it. Those of us at Gbawe Makati, we experienced it. It was terrible. And then when I experienced that, I said to myself, for the people that live in earthquake zones and earthquake-prone places and all that, like the Philippines, like Turkey, and all that, Charlie, it will be very disastrous. And I feel, though we have lost a brother, Christian Achu, but if I put myself in what he went through, it will not be pleasant. The whole thing shakes and buildings are collapsing. But we have got certain agencies and departments, institutions in Ghana that record of some of these occurrences, the data of such. Okay. We also have got forecast, or meteorological data that also keeps track of the things that are happening within our forecast realms, so that now they can also come back to inform us that, yes, we should expect some rains coming. I don't want anybody to say that Ghana's own doesn't work. Please, it has worked for a couple of times. Let's give them that. It works sometimes. It works sometimes. Yes. Even abroad, sometimes they miss it. Sometimes they miss it. They that even have the advanced technologies and all that, sometimes they miss it. I have seen it before in London, on ITV. On ITV, they announced that something was going to happen. It didn't occur. The guy resigned. So it happens. Let's allow. So this is just to explain, to let you know that we have got discipline-specific databases also. Now, we have also got databases that are based on the intended usage. And so how they will be used, and then the time sensitivity of the information gathered from them. For example, for those that will be dependent on how they will be used, okay, we have got companies or databases that support day-to-day. See, we use it day-to-day. We use it for our operational activities. Those are operational databases. Sometimes you call them online transaction processing databases, and then also transactional databases or even production databases. Example of such would be what we use in the banks. These are day-to-day databases. What we use in the grocery shops, they're also day-to-day, databases. All right. Then we have others that work with, time sensitive. They are based on time sensitivity of the information gathered. And so we have, analytical databases as part of that. And they focus primarily on storing historical data. Okay, so even I have mentioned that the meteorological database, okay, it's indeed a discipline-based database. But you realize that this also comes into agree to becoming what? An analytical database, because it stores over a period, and per that, now they can make some projections, some inferences. They can now make some strategic decisions, inform us as to what has to be done because of what it stores over a period of time that informs what we should be expecting also at some point in time. Analytical databases comprise of two components. We have data warehouse and then online analytical processing front end. All right. Data warehouse is a specialized database that stores data in a format optimized for decision support. And the data warehouse contains historical data obtained from the operational database. So this contains data from another database, the operational database, as well as data from the other also external sources. These ones comes into feed to help us to make some strategic decisions. The online analytical processing, OLAP, is a set of tools that work together to provide an advanced data analysis environment for retrieving, also processing, and then modeling data from the data warehouse. And these things, example of such, will be what comes in to feed business intelligence. Okay, all right. So this now we are having a whole course discipline coming out called business intelligence. So if you remember, when I was going through the career prospects and all that, business intelligence specialist is also one of the things I mentioned. All right. So when we say business intelligence, what is it? It is describing a comprehensive approach to capture and then to process business data with the purpose of basically generating information to support business decision making. And so, yes, this is also one key area that a lot of people can as well go into that. Databases can as well be, classified based on whether it's dealing with structured data or unstructured data. Now, the picture you see in there gives us a fair idea of what the structured would be and what the unstructured would be. Of course, going through the unstructured, you realize that every one of us is producing unstructured data. For example, your email is producing some data. The chat, your WhatsApp is producing. Your X, your Telegram, they're all producing something, okay? Your transactions, the things you buy online and all that, okay? They are all producing data. The surveys you have been taking part in, the call center, social media, all these, the ratings and all that, they're all producing what? Unstructured data. They are coming from different angles and all that. Even to help you to understand this better would be social media. I mean, you can post letters and pictures or sometimes videos together. This is data, but you see, it's not structured that comes like a specific format that comes in. But this one is coming in mixed up with almost everything at the same time. All right. Yes, that is the unstructured component of it. Anyway, let's look at it here. So unstructured data is data that exists in its original raw state, in the format in which it was collected. All right. And unstructured data exists in a format that does not lend itself to the processing that yields information. Example of such would be we have what we call no SQL databases. Okay. And they are non-relational database. This course is basically hinged on relational database. But the no SQL databases are non-relational. We'll get to understand what it is later. And this stores data in flexible, non-tabular format. You see, the relational one stores data in tables. When we say tabular, tables. So you heard me say that we have employee records, we have student records. Database contains employee records. Okay, these records would be the tables. Now, later we come to see bigger thing that will be tables that now contains records in that table. The record will be the rows. Okay, so for example, when I pick the student record, under the student record, and I'm picking one student's record, for example, Theo's record, his index number is part of the record, his first name, his last name, his age, or maybe, yes, his gender, then the rest of the details about him, that will form the record about him, Theo. I hope you understand that. Okay, so this is to say, for relational databases, and specifically for when you look at the structured ones, the traditional databases, they store things like that, okay, in tabular forms, okay, in organized format like that. Non-relational doesn't store them in such. All right. Example of the non-relational databases or the no SQL databases would be, for example, when you look at it in the context of document-based no SQL database. We have MongoDB, we have the CouchDB, we have the Firebase, Firestore. Then when you look at it from the key value databases, we have Redis, Amazon, DynamoDB, Riak, and then others like the Column family databases. We have the Apache, Cassandra, the HBase, and the likes. All right. Now for traditional databases, which is relational databases, MySQL, Oracle, Microsoft SQL Server are all part of that. Having said that, if you have mentioned structured and unstructured, then somehow there can be a situation where we can have semi-structured data. And they are this data that have been already been processed to some, extent. And then, for example, will be the ones that we capture from the web pages. Okay. And then some of these examples would be the extensible markup language, the XML databases. And for the XML databases, what you see, the picture right there, you see would be how it presents itself. Remember, it's also capturing data. It has titles, it have headers, it has the artists, it has certain other documents, contents, data that are stored right in there. Okay, having mentioned all these things, now when you're looking at it, the database types, we have said, of course, we can classify them under the number of users, data location, usage, and all that, right? But some of the times also, much as it can be considered under the number of users, it also stretches to even fit into the location, okay, based on location, fit even into the usage, among many things. So let's not limit ourselves to thinking that because we said that it is just based on the number of users, it ends there. No. For example, when you pick MySQL, which is the last but two? Yeah, MySQL. MySQL agrees to single usage. It also agrees to what? Multi-usage. But under multi-usage, it agrees to work group. So it can be used for work group up to about 50 people. It can also be used from 50 and above, which is enterprise usage. It supports centralized, location. It also supports, distributed location. It supports operational activities. We can also use it for data warehousing. All right. And then also it goes into as well support SML functions. I hope that is okay, guys. And
Very
having
well.
said that, thank you very much. For this section, we have explained what the data and information are. We have differentiated data from information. We have explained databases. We have discussed the different types of databases. For every one of these slides, I normally will give you, things that will help you to do your self-assessment. And then whilst you go through them, I provide some of the answers beneath it. And so this will bring us to the end of this section. Do we have any question? If we do not have any question, I can now move on to the section 2 for today's class. Any question? Any question, guys?
Yes, sir.
Oh, go ahead. Go ahead. Sorry, go ahead.
Okay. My question is relating to information, and then the definition, if it's used for decision making, then it is. So I want to ask, is there in any case that process data can be called an information, but it's not necessarily going to be used for decision making?
Okay, so I thank you very much for the question, but it is not because it is used for decision making that makes it information. All right. It is information because raw data has been processed. Okay, raw data has been processed. Okay, let me help you. Ghana has we are generating a lot of data today. We generate a lot of data. And much as we generate a lot of data, that would also tell you that somehow most of the time we process the data to know, and get some information out of that. We may have the information, but sometimes we don't take any decision on that. Again, you all have heard, you all got the data about certain numbers and other things. You have data. And then you heard the information that, hey, Casapreco has released their IPO. You have that information, but did you decide on buying some of the IPO? How many of you purchased it? You see, you had information, but you didn't purchase. And there could be a lot of factors that would influence that. For example, my past experiences with certain investment that I did US tilapia, I did Safeway tilapia. I had the data, all right? And then I processed it into information. I heard about these guys and I went to invest. When I went to invest, the outcome was not pleasant. And because of that, it killed my desire to go into any other thing such as that. So even when I heard about others, I got the information. I did not take any decision on that. I did, or maybe, of course, failing to decide means you have actually decided. I hope you agree with me on that. When you fail to decide, it doesn't mean you have not decided. You have actually decided that you are not going to decide. Is that okay? Or am I confusing you? Yeah.
It's understood.
Yeah, it makes sense because now you are saying that, okay,
and we ask you a question. So what do you think about this? No idea. You have decided to have no idea. or for me, I don't want to comment.
You have
You
decided.
understand? So you have decided not to comment. So it's also a decision. Okay. So I just want to explain by saying that it's not because that it helps us to make a decision that makes it information. It is actually information because we have processed raw data. Raw data has been processed, and that is how come now information is out of that. And based on that information, then when we now make some inferences, okay, we now, because the information will be, it will reveal a pattern, okay? It will reveal a pattern. You have gotten to know, like I shared earlier, that the guys that comes to buy beer when it is football season, the moment they come around, the next thing is, oh yeah, they remember to grab what? Diaper. And you have this data over a period, and you have been able to check with that. You have seen a pattern that, oh, any guy that comes to buy beer sometimes buy what? They buy diaper, or maybe they buy condom. If that is the information you have, that is the pattern, the trend you have seen. As the manager, you can decide that, okay, then why shouldn't I make it easy for them by positioning maybe the condoms or the diapers close to the beer stand? So they don't have to now move around. Sometimes people may forget. So now the moment they see this, now their eye will catch this one, so they can grab this and grab that. Then it will boost up sales of what? The condoms and then also the diapers. I hope that makes sense to you, sister.
Yes, please. Thank you.
Fantastic. You're welcome. Yes, Andrew Scoffy.
Hello, sir.
Yes, go ahead.
So I want to add up to the one that you just said. So I can we say that it's meaningful? That's why it's being called information.
Yes, it is meaningful. That is why it is what? Yeah, because we have processed it to bring out a meaning.
Yeah.
Yeah. Yeah. If you check right now, if I ask you all to mention where you are, it is data. Okay, let me ask. Andrew, where are you at the moment? Where are you located now?
I'm at Tema.
Tema, good. Theophilus, where are you? Theo, are you there? Or any other person can mention where you are. Some people will be mentioning some things. You maybe you hear some of them may repeat. You see, Edward is in Takrade. I'm sure he's not the only person in Takrade. You see, these are isolated data that are coming in. Because when you plot it on an Excel sheet, you will get different Tema, Takrade, Kumase, Bolga, Wa. Somebody is even maybe, as we are speaking, is in Toronto. Bole. I don't want to believe that you are in the Bole SHS. Techiman Kwanta, right? Yeah. Somebody's where in Kwanta?
Timan Kwanta.
Where is that one?
It's at around Kwame Danso area.
You see, now is it Kwame Danso area? Another person will say Aplao, another will say Togo, Kumase. You see, but if we take our time and we collect every one of these things as you are mentioning, because you're about 130 something, we will see a pattern in there. We will see a trend. We'll be able to process to know how many are from maybe Greater Accra. Even if Greater Accra, how many are in Tema? How many are in Accra proper? How many are in somewhere, different places? How many are in Ashanti, Kumasi? How many are in Ejuso? How many are in Takrade area? How many are at maybe Second D? How many are at Takwa for Western region? You understand? You can, then it will give us a fair idea of how to handle things. Because when we get to know now the distribution, okay, when we get to know the distribution, we can then make a decision based on that. I hope you get it. We can now make a decision based on that because of what we have, the meaning we have teased out of the data that we have collected, the individual data that we have. If I say mention your ages, you mention. But at the end of the day, we can also now make some meaning out of the average age for this one, this class is this. And based on that, maybe we should now decide on how to approach things. Maybe the IQ level of this class is this. The average IQ is this. So that would inform maybe how I should be teaching. I hope you understand what I'm trying to say. Does it make sense, guys?
Yes, perfect sense.
Fantastic. If that is done, I guess we can move on to section 2. If you agree, if I have your consent, can I move on?
Yes, sir.
Yes, please.
All right.
The last slide, please. Can you
Yes.
go back? Kindly go back where the table is.
Yep.
Yes, this one. So when you look at the products against the number of users for the single users, some are carrying the equip. What does it mean?
I am not really sure from the legend what it means. They would have probably communicated down there in the legend what it is. But for the asterisk, that is what it means. But the cube, I'm not sure what it is.
Okay.
I may have to check on that, and I can check and get back to you.
Thank you.
I'll write it down and look for it. Thank you for that. I'll check it and get back to you on that. Thank you.
Okay.
Any more? Okay. All right. Then we can move on to the next one. Thank you, guys. This is the longest, so the rest will not be that long. Okay, we are switching on to section 2. And this section, this section is going to look at the evolution of database systems. Also, it's a bit long. The evolution of database systems. Okay, so as usual, yes, there'll be the side of it that introduces the unit and all that. So I'll skip all this side of it. But for this particular section, at the end of the day, you should be able to describe the evolution of database management system, explain the characteristics of file-based system, and then identify the limitations of file processing systems. And then, oh my goodness, I have only 20 minutes left. Are you serious? Then discuss the reasons for the development of the DBMS, right? Okay, so let's move on. So the question would be why database design is important. So as we are talking, describing things and all that, at the end of the day, one of the things we want to come to hit hard would be where we understand, come to terms with what we are going to design. The design of our database matters a lot. It's very important. Now, if we are talking about the design, we are referring to the activities that focus on the design of the database structure that will be used to store and manage the end user data. Now, for a database to be properly done or designed, okay, at the end of the day, you need to be able to identify precisely the database expected use. What is the database going to be used for? Come to terms with that. Number 2, if you are designing, for example, a traditional transactional database, your focus, your emphasis should be on accurate and consistent data, and then the operational needs. An example of such or transactional database would be what we use at the banks, what we use at the grocery shops. Okay, these are transactions. They help in the day-to-day activities. If they are helping in the day-to-day activities, what is coming in should be accurate data. Remember, I said that for you to make a good decision, your data should be accurate. It should be timely as well. It should be relevant. All right. Yes. So if you're looking at it based on what it's going to be used for, then depending on what exactly it is, and a clear example, if it is going to be used for transactions, day-to-day activities, then what am I supposed to focus on? Or what should I accentuate? Accentuate or emphasize accuracy, consistency of the data as well, right? Then if I'm also looking at designing what I call a data warehouse, Okay. Then the emphasis also should be on the historical data, and then that which accumulates over a period of time. So these will be some of the things that we need to be focusing on. Now, with how we have transitioned to getting into the times of the database systems, all right, we want to start off by looking at file systems and how they are processed data over a period. So this is going to help us to understand what database is, what it does, and then the proper way to use it can be clarified by, considering what a database is also not. Now, the explanation I'm going to give you all through is going to be a guide, please. It can be so helpful if you can understand, all right? It can be helpful. It is going to help you so that you don't make certain mistakes, commit certain mistakes that we have seen, or I'm going to show you from the earlier versions of things we have used in managing data. Now, we start off with the first one, which is the manual file system. This is the very first one. And so the picture you see, for those of you who have not seen a cabinet before, that is a cabinet. This one will sit tall, standing tall. And then you see the cabinet drawers. The picture you have seen a drawer pulled, and you see, a pile of files right in there. Every one of these files will contain, folders will contain files. Every one of these folders will contain files. So the manual file system, in order to be successful, an organization must come up with systems for handling, our core business tasks. Even you want to check, every institution, being it the formal or informal sector, there are ways and means that they handle their tasks. Our mothers in the markets may not have a formalized way of doing things, but somehow it is also an informal approach of handling their tasks, keeping records, storing things. So when they go to buy the goods, how much they bought it. Sometimes they may not write it, but they have it in their head. They know how much they used to purchase. Then selling, how much they have to put on. Then when they are done, even as they sell, they'll be tying the thing at the tip of their wrapper or their cloth. When they are done, they spread it out there. Then they begin to stretch out the monies, count them. Then they separate them into, this is how much I'm using to go to buy another. This will be for transport. This is my profit. Okay. That is a way. That is how they have used. So using that to guide us right now. Historically, we have also gone through certain transitions or processes of also storing data, handling certain business tasks. And they have done it in the manual way. We have seen paper and pencil, or maybe paper and pen systems that have been done so far. And the papers with these systems were organized in order to facilitate the expected use of the data. All right. Then also, then came the file folders, and then also these cabinets. Every one of us would agree that this is good. It makes it neat. It makes it fun and nice. I don't know. Do we have anybody that works at Birth and Death here? Birth and Death. Is it still a department or now it's an agency? Birth and Death. I have had the opportunity of sitting on an e-government, is it procurement? That was in 2012. E-government procurement group. I represented my organization. I used to work in a government agency, and I met some of these institutions, some of the reps from these institutions. If you go to a place like Birth and Death, we have known that over the years have been storing and keeping our data, our records, in folders. Who can relate to what I'm saying? Even when you go to the hospital, sometimes you go, they say they are going to pick your folder for you. So you present your card, then they'll go to the record side and go and look for your folder. Sometimes they don't find it, and then they will come and open another one for you. And so for you, that same one person, there are about 2 or 3 folders of yours sitting in a particular hospital. But these days, things are changing. They're embracing new trends and all that. Yes, so this is what we had. I mean, when the data is few, when you don't have too much or maybe too many information or maybe records to deal with, it is okay. It's easy to handle. But imagine you are handling the data, the records of the Ghanaians. There are about 36 million Ghanaians all through. It will be overwhelming. It will be too much to handle. If there are only a few, if you're in an institution that handles about, let's say, maximum about 100 stuff. I mean, it's easy. HR can easily pull everybody's folder. It's so easy to work with. And that is a system that we had. I'll be exploring the issues that, or maybe I can just mention some of them. If you look at that, if we are to generate, let's say, a report of how many people came to a hospital in a month, how are you going to do that? Let's think through. How would you be able to produce to management or the owner that, oh, so the past 3 months, we recorded about 500 cases of typhoid. And out of these 500 cases, about 50 were women, about 400 were men, then the other 50 were children. And even that, the children, these are their age. How do you do that? It will be too difficult to generate reports. And remember, when you don't have data, you have not been able to process it, it comes in to affect certain things. You don't make the right decision. And I cited an example with the population census thing that my former student told me about. Okay, so these were some of the issues that we had with the manual file system. So much as it was helping us managing our data, it became too complex to handle, especially when the report and the documents now entered into. Sorry, I just need to activate my mouse. When they entered into the thousands, the millions and all that, you can't handle such. All right, it becomes difficult. Now, with those shortfalls in place, it led to the introduction of an enhanced version, which would be the computer file system. The computer file system. Now, the challenges of the manual file system, of course, led to the hiring of some specialists, called the data processing specialists. And what was their job? Their job was to create a computer-based system, all right, that would track data and then also produce required reports. It was meant to track data. So basically to handle the lapses of the manual, this one comes in to help us. All right. Now, to better understand the computer file system, which is also known as the file system. So now when you hear me say file system, I'll be referring to the computer file system. All right. We need to understand some specialized vocabulary right in there. I've said some of them in passing. Some of them may make sense right in here. But this is going to introduce you to the jargons that works under that new phase that we entered into, i.e., moving from the manual file system to the computer file system. There are certain jargons that comes with it. For example, you see data, you see field, you see record. Record, you have seen it already, right? You also seen file. What are these things? What are these things? A data still means the same. It is raw facts, such as your telephone number is raw. Your number, your date of birth is raw. Your customer name. All right, these are raw. Data have little meaning unless they have been organized in some logical manner. Then also another jargon or vocabulary we are seeing is field. Field. Pay attention, guys. Field. This is a new thing. I just don't want you to be confused. A field. What is a field? A field is a character or group of characters. Okay, it can be alphabetic or numeric. Sometimes it can even be alphanumeric. That has a specific meaning. All right, so a field is used to define and store data. Hello, guys. A field is used to define and store data. So now we know data. What data is? The raw fact. But what is used to store that raw fact, that data, is called the field. And when you look at the field, you see that it is a character or a group of characters that has a specific meaning. So who can give me an example of a field with the explanation of data and a field? Who can tell us an example of a field? Is there anybody that can give us an example of a field?
Yes, sir.
Yes.
Like student's name.
Student name. Your name is a field. Why is it a field?
Student ID.
Student ID is a field. It's a field. Why? Position, yes. Because anyone, thank you very much, guys. Any one of the things that you have mentioned, if you pick, let's say, first name will take what? The data called first name, which in your case, if it is Theophilus, if it is Edward, if it is Edwina, that is that data. And when you break it down, you see that it is a character or a group of characters, because Edward is character EDWARD. These are a group of characters that come together. Okay, they are used to define that first name. So I guess it makes sense. It makes sense. Now, when you look at record now is what? A logically connected set of one or more fields that describes a person, place, or thing. So, for example, the field that constitutes a record for a customer might consist of the customer's name, address, phone number, date of birth, credit limit, and unpaid what? Balance. So, if we understand this, then I also want to ask a question. Can you give me an example of your record? Somebody can just lift up a hand and tell us your record, if you can mention your record as far as this school is concerned. So when we see the record of you or about you, can anybody give us an example? Maybe use yours as an example. Do I have anybody?
I would like
Yes.
I would like to try.
Okay, Sichofe, go ahead.
My name, my student ID, and then the record of the courses I have done so far. And then
Fantastic.
my results as well.
Great. Okay, now with what he said, it has moved to another realms, and I will take it now as perfect. But when we move along the line, later on, we realize that what he said may not be the perfect one. Why? Because you can break other records, like your marks, your scores, over a period. That can also be stored differently. So
Okay,
that,
sir.
don't confuse yourself. Yes, go ahead.
Could that be your biodata?
If you say biodata, how do you mean?
Okay, your name, age, where you from, marital status. Yeah.
Yes.
So
yes. That is your record. So what the everything about you that we store in this school for under student record, your index number, your first name, your last name, your gender, your age, if it is date of birth, fine, but your age, okay, maybe your phone number, all right, maybe where you stay. This is your record. This is something the thing, as somebody said earlier, are these the attributes? These are your attributes. When you put them together, these are the things that describes you.
Yes, sir.
Fantastic. Then we can move on. Then also we have a file.
Hello,
now
sir.
we know. Yes. Go ahead, please.
Please, I have a question.
Go ahead.
Can someone transcript? Yeah, I'm asking, can someone's transcript also be termed as a record?
Yes. When we pick your transcript, we can have a record of that. That is why I said the first person that spoke, I said it's perfect. But when we move on, you realize that sometimes you may have to now, when you start doing what we call normalization, you may create new tables. So your marks and things can now maybe even begin to stand alone as a table on its own. But it can still contain record about you. All right. And that is the same thing. Again, what you said, because if you know, how do we get to know your marks all throughout the, let's say, the 4 years you have studied, so it can generate your transcript for you? How do we keep records? We store the marks, store your accumulated what? Average. That is how come we know per semester your average, per year your average. Then the CWA will come for the very final. So when we print your transcript for you, It spells out all these details. There's a way we store them.
Hello, sir.
Okay. Yes.
But by definition, wouldn't the transcripts fall under a file since it has a record of, like it has different records that have been accumulated over time?
Amazing. Amazing. I like it this way. And I said that, do you remember I said that it will contain records about you? So yes, that transcript will be that file. Even student, if you heard me say student, okay, a collection of related records, student records. You heard me say student records. Is that not the case? When you pick student records, a student records, so different records of students, when you put them together forms the file called student.
Okay.
Does it make sense to everybody? The bigger thing, I'm going to show you an example right now. Let's not even confuse ourselves. Let's see an example. This is an example of a file. Again, go back. A collection of related records. Okay, a collection of related records. Now, this is what? A file. And it has what? Related records have been collected and put together in this file. What are the related records? Record about Alfred A. Ramas. Record about Leona K. Dune. Records about Kathy, all the way to Olette K. Smith. These are different records. They are related. They share similar things. And they are put together in a file. Is it okay, guys?
Yes, sir.
Now, great. C name, C phone, C address, all the way to REN. These things are fields. They are fields. And the fields now contain the data in them. So when you come under C name for Alfred A. Ramas is the data. For that same person, the data of C phone is the 615-844-2573, and the rest of the things continue. Okay? So they are containing individual data right in here, captured in fields. And when you put each one of the fields together, it forms a record about every one of them. And when you put the records together, we get a file. Is it clear?
Yes, sir.
Great. Admin, in case we run out of time, is there a way I can record the other sections and put them on the and so you can put it on the system for them?
So you can even upload it on the LMS so that we can go there and
okay, because this one they are going to upload it direct. So I want to, so that you don't miss out. I don't want to miss out any of the sections I don't cover. I want to record and put it there for you so you don't miss out. Okay.
Yeah, that will be fine.
Great. I'll do that. Even because I see we have only 8 minutes. We have only 8 minutes. I wonder how, because even this is session 2. Okay. Thank you for that. Now, because we understand, we can move on. This is also a file called what? Agent. Guys, let me give you this maybe a warning ahead of time, or maybe an alert. Okay, or a prompt. Okay, you see, we are seeing file, we are seeing fields, we are seeing records and all that. As we move along, you'll be seeing them, you'll be seen as use different jargons. I told you we are using these jargons because we are considering them under the computer file system. Do you remember?
Yes, sir.
Fantastic. So now when I switch into looking at the database, we will also now come to see some other jargons. Some of you go like, oh, but this one, you said it here this way. Well, how come now it is different here? It's basically the same, only that now it is coming out in another way. Because today you are hearing file. Another day you hear about entity. Okay, you hear about table. It will sound some way, but it's basically revolving around the same thing. Is that okay, guys?
Yes, sir.
Great. I hope it is clear and you understand what I'm saying so far. I hope I am not sounding too technical.
Yeah, good.
Fantastic. Don't give up already, please. If you want to give up, let me know. Don't give up. This is
We are good. We are good.
Thank you. Enjoy it. Enjoy it. It is fun. Enjoy it. As far as I'm concerned, I'm having fun. So, okay, let's move on. Now, under the same computer file systems, right? The issues with this one also started. Remember, the manual file system had its own issues. Then they embraced the computer file system, courtesy hiring data processing specialists. Data processing specialists now they started creating for us small programs that could aid us to access certain files. Okay, but what are some of the issues that came up with this? Well, when businesses or business users wanted data from the computerized file, what happens is that they sent requests for the data to the DP specialist. Imagine you want to access your money at the bank. Then instead of going direct to access the thing, you call the bank manager. I beg, can you tell me how much money I have sitting in my account? Okay, what if his phone is out of coverage? What would you do? Or he has traveled. That means you won't have access to your thing. So you see, it doesn't make it nice and cool to work with that. Again, for each request, the DP specialist had to now create. You see, each request, any request that comes in, now they had to create programs to retrieve the data from the file. And some of the files would be the customer file, agent file, as we have seen them. They will now create program. So there will be a specific program that will help them to now retrieve from a particular file. You can just imagine how terrible this is. So the time it would take for you to code, because you are going to program. And we all know coding is not a joke. Now, it even does not end there. For you to manipulate the data, the user had requested. It is also another thing because, for example, if we now want to access something, we have to write the program. Apart from writing the program to access the file, what if we now want to manipulate it? Such as maybe we may want to now update the content. Okay, we want to alter certain things right in there. That is another process. Now, then they'll go ahead to now present the data as now printed report to you. It's even going to be printed report. So if they are in their millions, are we going to print them all and make them available for use? If a request was for a report that had been previously run, the DP specialist could now rerun the existing program and provide the printed results to the user. Just think through this one. Is it not too much of a work? Doesn't it sound okay? Again, as more and more computerized files were developed, the problems with this type of file system became apparent. Understanding the shortcomings of the file system enables you to understand the development of modern database. This is where I want you to understand. So then, of course, many of the problems are not unique to the file system. So the problems you are going to see is not isolated to the computer file system or the file system. Guys, this is to be a guide for you such that you don't commit the same mistakes. Failure to now understand such problems is likely to lead to their duplication in the database environment, even though database technology makes it easier to avoid them. So what are some of the problems that came? There's lengthy development times. Also, it was difficult getting quick answers. Then, it was complex. The administration of such was too complex, too cumbersome. And imagine even the challenges that you go through to now code it, manipulate, print the report. I mean, even security, having to enforce security and share data was also another problem. and then it involved a lot of what? Programming. I will skip these things because they are self-explanatory. I'll skip them. They are self-explanatory. Okay. I've already mentioned most of these things, so I can move on. Maybe the side that I'll say extensive programming, just to highlight that bit of it, would be, anyway, do you have a class after this one right away?
Yes, please.
Yes,
3:45.
Okay, 45. So, would you be okay if I finish off this section?
Yes, sir.
Okay, all right. So when we say it involves extensive program here, let me show you one thing. Let's say that now it becomes apparent for you to now change, let's say, a field. Okay. All right. If you want to make a change to a field, and remember what a field is. Let's say the date, the name, the phone number. What the data specialist would have to go through would be, number one, he writes the program such that it will go and read a record from the original file. Then it transforms the original data to conform to the new structure's storage requirement. Then he will write the transformed data into the new file structure. Then the rest of the steps will continue for each of the records in the original file. Come on, guys. That's a lot. That's a lot. So remember, we have even mentioned now if you're changing the field, okay, if you are changing the field, remember we said that transform the original data to conform to the new structure. So what it means is that if we are changing a field, that is a field, a structure it agrees and it knows already. If you make a change, then it means that it has now been changed to a new structure. Any other system that knows the old structure cannot work with it because it is now a new structure. It's like when I was coming to Ghana recently, I saw this lady. I think she went to do her face in Turkey. I transited through Turkey and I saw her. Guys, when they were checking our passport for us to board, they looked at her and put her aside like 5 times. Then she put a document that said that she came to do surgery because the face, and the pic, it was totally different because the one we know the structure we know in your passport is different from the other structure we are seeing in the now. So any other person that related with you based on their old structure, now they are seeing a new structure. So which is which? So then we also come in to say that the file system had an issue. Some of the issues that it had again would be structural and data dependence. And then data redundancy was also another issue in there. Then there was the issue of lack of design and data modeling. So of course, looking at the issue of structural dependence, I've already told you, if we are changing date of birth, okay, if we change the date of birth, all right, just check something. Adding, even, or maybe want to add it, adding a customer date of birth field to a customer file, it will require us going through that 4 steps that I told you already. If you remember, the 4 steps I mentioned. Now, given this change, none of the previous programs will work with the new customer file structure. Therefore, all the file system programs must be modified to now conform to the new file structure. In short, because the file system application programs are affected by change in the file structure, they exhibit what we call structural dependence. Now, apart from the structural dependence, there's also data because we know it. For example, you change the data type. Before you said age is what? Integer. Or maybe the price, you define price to be integer. Then you came back to now, or maybe you came to realize that no. But price, sometimes when you can quote price by saying 40.09 pesos, 40 Ghana cedis, 90 pesos. If you can say 40 Ghana cedis, 90 pesos, how do we handle the 90 pesos? So let me change from int to maybe a decimal or maybe to a float. The moment you change it, the systems that have known this system before knows it to work with int. It doesn't know decimal, it doesn't know float. So then we may have to now go and change or said that it can now would work with the newer data. So it depends on the data it has used with. It has used all this while. It knows this data. It knows it to be like this. If you change it, it doesn't know it again. That is another terrible thing that comes with it. Okay. Let me see. All right. No comment. Okay. Let's move on. Does it make sense anyway? Is it clear? All right. Now, there's also another issue. Thank you. Another issue called data redundancy. What is data redundancy? This exists when the same data are stored unnecessarily at different places. And you agree with me. Remember, it's dealing with files. So you write programs for specific files. So the customer file, today, remember, if it is, let's say, Melcom, an employee who buys something from Melcom, how do we classify that person? And how do we store that data? Who is that person? The person number one is what? Employee. Is that not the case? Then number two, the fact that the person is an employee doesn't mean when they come to buy, we don't keep data about them. This time, what data are we storing about them? We are storing data called customer. We will not store it in there as what? Employee. The person is still a customer. It's like staff of GCTU right now, who are also students. They are staff, they are employees of this university, but they are also what? Students. We don't capture them in the student records as what? They will not have a different ID. They will have a student index like you all. So then again, it will come in to say that we will store data about that staff in the employee file. Then we will store the same or maybe another data about that same employee in another file called students. Maybe when we go to the HR, they have another file for that employee called maybe payroll. So you see, then we are having the same data sitting at different places. It's like Ghana right now. We have a lot of data redundancy. We have a lot of data redundancy right now. Why am I saying this? Go to passport office. They have data about you. Health insurance have data about you. EC also have got data about you. What is the other one? Identification authority. I've got data about you. They are the same data sitting. They may not necessarily be the same, but it's similar, of course. But the rest of the things will be same. Your name, your age, and those things will be same. Same data sitting at different places. That is data redundancy. And in the case of computer file system, is the same thing. I hope it is clear on that, guys. Are you clear on that? I want to hear you guys. Are you there? Are you clear on that?
Yes,
sir.
Fantastic. Then we have uncontrolled. You see, when we don't control the data, when we do not control such data, guess what is setting? It brings in
yes, sir.
Yes. Thank you. It breeds grounds for what? Poor data security. Having multiple copies of data increases the chances of a copy of the data to be susceptible to unauthorized access. Yes. Then anybody can now access it. Then there's also what we call data inconsistency. When different and conflicting versions of the same data appear in different places, it conflicts. It's inconsistent. This is not political, but I'm just citing an example. We were in this country where we had a man of God. I'm also a pastor anyway, so when I use that example, just a man of God, we had, there was what? Who had about 3 names. He had about 3 names. See, it did not help with the consistency of data. It was inconsistent because you cannot have now, for example, my name is spelled as Isaac. My name is Isaac Baffour Senkyire. The Baffour is Baffour. Okay, maybe at birth and death, my name there is spelled right. Maybe when you go to identification authority, instead of Baffour, maybe the person who was handling it knows of a certain type of spelling and spelled it as Baffour. It sounds Baffour, but that is not me. Legally, that is not me. Maybe another place, the person spelled it as Balfour, Baffour. That is not me. But it will contain the rest of the things about. But you see, it is now inconsistent. It's not the same. It doesn't agree. Right. Okay. Still, on this same issue of data redundancy, it also breeds the grounds for what? Anomalies. Data anomalies. And now it's basically from dictionary perspective, it means abnormality. Okay, abnormality. And with that, we can have, the moment we have such, okay, then the integrity of the data is lost. When we say data integrity, we mean to say that the condition in which all the data in the database are consistent with the real world events and conditions. So my name, if it has integrity, would be consistent all throughout. So data consistency and integrity goes hand in hand. But of course, under the anomaly right in there where there's redundancy. For example, there can be data, this data anomaly thing can now bring us also into a situation where we have what we call update anomaly, insertion anomaly, and deletion anomaly. Okay, for some of these systems, based on the file-based, computer file-based system, okay, the challenge with it, if I should blow the table you see, this table is the same table I showed you, the customer table. If you blow it up, you realize that this one will raise an issue. For example, when we check, let me just blow this side, just this, I'm done, almost done. When you blow this table, okay, now when you look at it, there's an agent called Leah F. Han. First, second, third, fourth, fifth column. Under the E, systems, the E. Do you see A name? A name is the agent name. There's an agent called Leah F what? Han. Now, if this Leah has a new phone number and we need to update the phone number, how do we update it? Do you see the problem created? That means anywhere we see Leah F. Han, we have to go and change the phone number there. This is update anomaly. And this will work so well when it is a small file you are dealing with. But what if the file contains millions, 36 million Ghanaians? How do you locate Leah F. Han and change all the whatever, maybe 1 million places her name appears, the phone number? So this is telling us of what? This is an update anomaly. Right. Then also for insertion anomaly, okay, insertion is for example, if we also want to insert, how do we handle that? Now, if only let's say the customer file existed, to add a new agent, you'd also add what? A dummy agent. Let's say the customer file is the only thing that existed. We didn't have anything like agent file. If we need to add now a new customer, this means that now we need to now go and look for what? Create a new person called agent, because every customer would have to get an agent, which doesn't make sense. Again, if you also want to delete, by deleting one person, sometimes if the person is attached, let's say an agent, and we are deleting that customer, and that is the only thing in there, we may delete even the agent, meaning we will not have a record of any agent in there. So this is where we come in to say that we have what we call anomalies right in there. Okay. All right. So the problems, again, there's also a problem of lack of design in data modeling. There's a way you build. It's like how you build. We have building blocks. We have a way that you draw your plans. Then they will map it on the ground. Then they will start building. This one did not have its own way it follows. But when you come under databases, it has its way we model data. And we are going to get there. And that will bring us to the end of this, where we have looked at, describing the evolution, explaining, identifying, discussing. And there are sample things to help you to access it. That ends it. If you have any question, you can go ahead and ask. Other than that, I'll do the recording of the section 3 up to the 6 and make it available for you. I'll do it before I leave my office. Yeah, do we have any question? Any questions, guys? Okay, since there are no further questions, I want to say thank you. I really enjoyed myself. God bless you. And I'll see you again next week.
Thank you, too, sir.
Thank you, sir.
Great. Right.
Thank you. Bye-bye.
Bye.